Oh, well, I like to all sometimes invert the phrase, so the science of materials. And so for me, that means, the physics of materials and how they behave, the chemistry of, how they form and the structure, form their structures, and then the defects, are probably the critical, almost the defining thing compared to materials chemistry and materials physics. So, how defects control properties and how we engineer those defects is material science. Well, I think right now it's very exciting because we have new tools to look at the behavior. So we have some new techniques that allow us to study very thin layers and very small samples, be able to measure properties under very high pressures in order to manipulate their properties. Thin layers we can use where we can create defects in the layers and see what happens. So a lot of the excitement is new capabilities, because it's just superb faculty and students. Everybody's just great and hardworking and collaborative, and everybody's on the same page. Everybody's on board to move everything forward. So it's a great place. Well, I think I probably decided sometime when I was a postdoc that that I wanted to be a professor more than I wanted to sort of stay in the national lab or industrial lab areas. And I think mostly because it gives you a lot more freedom of doing more different things and working with students and a larger variety of colleagues who are working on different areas. So it's the breadth and the people. I don't know. I would say that the most important accomplishment actually has been the development of the new methods, for thermal transport measurements. So we call it time domain thermal reflectance, and that's been developed over some years. So actually it's not just one thing, but it's been a development of a tool, and I'm very proud of that. And I don't know, sort of single paper. Probably the ultra-low thermal conductivity paper in science. So there's a paper that describes, it was really serendipity. We found a material that has the lowest thermal conductivity that's ever been observed in a solid that doesn't have porosity. So for a fully dense solid, and this material has a thermal conductivity of about twice that of air, or to calibrate you, or about 4 times less than a piece of polymer. Typical polymer. So it has about the same thermal conductivity as styrofoam, but it's a dense solid. And there's very interesting physics about why that's true, which is a little complicated, or why we think it's true. And we're still looking, so it's really exciting because we're still looking for things that might even be lower than that. And I think maybe a different group at a different places has found something, and we'll be able to follow up on that soon. So it's it broke a conventional wisdom. So we had a kind of conventional wisdom about what the lowest thermal conductivity could be, and it turns out that was wrong. And now we know that there are other routes to making it lower. So the end result would be, where would you find the perfect thermal insulator, right? So you can start thinking about those sorts of things.
Right.
Mm-hmm. Oh, well, it's mostly about people. So it's mostly about hiring faculty, hiring lecturers, admissions of graduate students, meeting with the undergraduates about what we should be doing with the course, how we can be continually improving the courses for the undergraduate program, meeting, alumni, donors, like I say, it's mostly that. Right, it's mostly about the people, and this, and also in keeping managing the staff. So, such as, Cindy Brya and the communications efforts, Allison Winter and the advancement, efforts, Nicole Robards and the laboratory, keeping the laboratory going. So people, and then also I have responsibility actually for. Basically for the space and facilities that we maintain. So the instructional facilities, the 2 buildings, the Material Science and Engineering building and the ceramics building. So there's always a lot of renovations going on. We're working on you know, we're probably working on at least, probably close to $2 million of renovations right now all put together. And, you know, and figuring out what has to be, you know, keep that all moving forward. Oh, I think a love of discovery, let's put it that way. So I hope that's what people come out of here with, that appreciation and a love of learning and discovery and, you know, how we, you know, learn about nature, right? Materials are one part of that, but, you know, but it's more general than